Students, this question was asked in Neet 2024 from the chapter Magnetism. In a uniform magnetic field of 0.049 Tesla, a magnetic needle performs 20 complete oscillations in 5 seconds as shown. The moment of inertia of the needle is 9.8 into 10 to the power minus 6 kg meter square. If the magnitude of the magnetic moment of the needle is x into 10 to the power minus 5 ampere meter square, then the value of x is how much? Okay, student? Let us find out. Students, we have studied from Newton's second law of motion that until and unless an external force acts upon a body continues in its state of rest or of uniform motion. Okay, so for motion of every body, force is essential, and the analog of force in circular motion is called torque. Okay, student? So any body performing a rotational motion or oscillating in a force field, it experiences a torque, and this torque is a student that is noted by tau. Its symbol is tau, and it is a vector. And this is, we have studied force into the radial vector. Okay. And in case of a magnetic field, if this is the magnetization vector of the needle and B is the externally applied field, then what will be, student, the expense per tau? That will be M cross B, or that will be, student, MB sin theta n cap, where n cap is the unit vector perpendicular to both the vectors M and B. Okay, students. So what will be the magnitude of this torque? This magnitude of torque will be MB sin theta, and you know this theta is very small. The angle of oscillation of the magnetic needle is very small. So sin theta can be equated with theta, student, and we may here write MB theta. Okay, student. So students, what is the formula for the angular speed, angular frequency of a body oscillating in a force field? That is omega is equal to, that is twice y by t, where 1 by t is the frequency of the body, or t is the time period of oscillations or rotation. Okay, student, and this is equal to root over MB theta by I. Okay, or T will be equal to twice y root over I by MB theta, and for small theta this may be considered as 1 degree, and here we may replace here MB into 1 or MB, and this is the formula for time period of any magnetic needle placed in a magnet. We have studied it in the theory portion. Okay, student. So what is T here? What is the time period? You see, it is completing 20 oscillations in 5 seconds. So T is equal to 5 seconds and N is equal to 20. So what is the time period? Time period is equal to T by N, or 5 seconds by 20, that is equal to 1 by 4. Okay, student, here we may write 1 by 4 is equal to twice pi into, what is the moment of inertia? It is given 9.8 into 10 to the power minus 6 kg meter square. And what is M, magnetic moment of the needle? It is given x into 10 to the power minus 5. X into 10 to the power minus 5. Okay, student? And what is B? B is given 0.049 Tesla, 0.049 Tesla. Okay, student? So we may write it like this. We may write it 0.49 into 10 to the power minus 6. Instead of 0.049, we may write 0.49 into 10 to the power minus 6, and we may cancel this 10 to the power minus 6 and 10 to the power minus 6, which are both in the numerator and the denominator. Okay, student, and we may also write this as 49 into 10 to the power minus 2. 49 into 10 to the power minus 2. Okay, and when this 10 to the power minus 2 goes upward, this becomes 10 to the power 2, and we may take it to the upper side, and here you see this 9.8 into 10 to the power 2 means this is 100, and this becomes 980 by x into 49, or we may write this 49 into 2, 20 root over 20 by x, that is equal to 1 by 4. 1 by 4 is equal to root over 20 by x, implies, let us square both sides, this will be 1 by 16 is equal to 20 by x. Okay, there is a pi here, twice pi by twice pi, we have left it, writing here, this was the 2 pi, so when we square both the side, this will become 4 pi square, okay, there will be into 4 pi square here, so this will be, x will be equal to, this, when this will go this side and this will go this side, x will be equal to 16 into 20 into 4 pi square, that will be 4 into 280, 8 into 16, that is 128, and this is the 0 pi square, which is in option for students. Okay, thank you.